Welcome, everybody. This is Coder Jerome. Today, we're going to be working on a few algorithms, data structure, some functional logic in programming. We're going to solve a few things. We're going to probably start a new course very soon. But today, I have received the privilege of being on Jake Coin 5000's channel to do this. So, I'm going to start with a few exercises. We're going to solve a few problems. We're going to get into the code, work on data structures and algorithms, what we do best, right? So, again, I thank Jake Coin 5000 for giving me an opportunity to work on this, to possibly do a course on his channel. Okay, so check the channel out. He's, building out a new channel there. But I'm going to go ahead and start coding here in a second. Jake Coin 5000 also has his own playlist courses. He's also a coder himself. All right, so he's going to bring some more languages to the table and have you guys check some things out. He also has some other things going on, some other things that he's going to be working with on the channel. So check him out. Right now, Coda Jerome has been given the invitation to work on a few things here with you guys. So I'll be hopefully getting the call to do some courses on the channel here. All right. So right now, we're going to start with our first one. We're going to work on a few algorithms here and solve some things. All right, guys? So we're going to continue with what we've been doing and working on, all right, in past lessons. Okay, this is Coder Jerome again, all right? I'm back, and I'm on the channel Jake Coin 5000, all right? So let's take a look here at what we're supposed to be doing. We're going to start with traversing a linked list, okay? And then we're going to insert into that linked list. All right, that's the first one we're going to do. Then we're going to move on to another data structure. We're going to do a few of them in about 3 different languages. We're going to work with Python, C, and Java, as a matter of fact. So I'm going to target a new REPL for those, and that's where I'm at, right? This is the platform go-to for those of you that have been working with me for a while, okay? Those of you that have been taking Coder Jerome's path, okay? Taking my courses and things like that, all right? I've been given all kinds of philosophy on repetition and things like that, moving through the code, understanding the code, the concepts, solving problems. All right, so we're going to do that here today on the Jake Coin 5000 channel. All right, so let's start with our first exercise, our first problem, that is. And this is going to be the linked list, okay? So you always have to get a node in there, right? You always got to get some kind of node. We're going to make it a class. This is Python, by the way. I'm going to start with Python for this one, all right? So let's take a look at it. In the node, we want the constructor, of course. All right, Python has a self instance and the data itself, okay? All right, so we want, to build that out with the parameters there, right? Get things set up here, get our node set up, basically. The root node, that is. So this is a linked list, okay? The creation of it, all right? And then we're going to move through it and then add some things to it. All right, so here we go. We're going to assign it like this, and then give it a next property to go through the linked list, right? So remember what a linked list is. Okay, it's a sequence of data elements. They connect together literally via links. So we have a connection present to another data element. And what are those connections comprised of? Pointers. Okay? All right. So next we could just say that there's nothing there. Use a generic T for your standard linked list. Okay? And we need another constructor for this guy. We need the head. These are standard terms for linked list. And we're going to define our own tprint generic print function, okay? Here, you're going to simply make a variable to the head while your generic print value, if you will, is not null. All right? Then you want to simply print tp.data, the data itself, and then tp equals the tp.next. So we're looking to traverse through the linked list, okay? So we have the head, we've got, we want to make him null for now. So let's just traverse through it. That's all we're doing right now. Here's our pointer object, t linked list. Okay? We have, what do we have here? We've got the pointer dot head to the node of 1. See? Pointer 2 to the second node of 2. Traverse through it, right? Pointer 3 equals node of 3. And pointer 4 equals node of 4. Okay, so pretty straightforward. We're going to go with 4 values there in the linked list for now. Our pointer dot head dot next is pointer 2. Pointer 2. Let's see here. Pointer 2 dot next is pointer 3. Pointer 3 dot next is pointer 4. Pointer dot tprint should get us something here. I'm gonna check my values here, and of course I see an issue with the looping here. Again, we're doing this live on the spot, okay? And what that means is that we're working together. Anybody who knows who I am, anybody who knows who Coder Jerome is, we work together. We do things on the spot. We solve the problems through repetition and hands-on. Okay, here we are. Okay, we're on Jake Coin 5000's channel. Hopefully I'll be able to do more work with Jake. Right now, I've got the privilege of being on this channel right here. We solve the problems. Any errors that we get, we solve it right there and then. Everything we do is hands-on repetition. That's how it is with Coder Jerome. That's how it's been. Okay, so we're going to look at what we have here. Okay. And we're going to see what's going on. Okay, all right. So basically what we're going to do here is look at the indent of this guy. Bring him within the while loop. I had a forever loop going because of that. You can blame it on the while loop for that. All right, so make sure everything's indented nicely. We have 1, 2, 3, 4 going through the linked list, our generic one. All right, so now we have it set up. We've got our data. Now we just want to insert something into it. We want to insert something towards like any area. All right, we want to insert anywhere is really what I'm talking about. So let's do that. Let's do that. Now we have it set up, right? You guys are working with me. We're working together. You got your hands on it. We're not copying and pasting. We're not really reading anything. We've got to get in here and implement it. All right, we've got to solve the problem. So what we want to do is insert. We need to think about the implementation here on insert anywhere. So what we're going to do is scroll up, and in here you're just going to say insert. Okay, like that. Insert self. Okay. Think about where you want to insert. Insert into n place, like that. The n data, maybe it's, some data, right? Some n data, or whatever variable you want to use, x data or y data. I don't know. Think about a good variable to use, right? So n place for the n data, which is basically the new data, right? So if n is none or null, then print nothing there. Let's just return at that point. And we want to say within this block, n data will go to our node class for the n data, right? Which is basically the new. I'm gonna rename this. Which is basically the new data, like that. See, and then our new data dot next equals n dot next, and then n dot next equals new data, right? So it's a swap going on right there. All right, so let's pay attention to the insert, as you can see. Okay, the insert, as you can see there. So now we have to find something we want to add, okay? And that should be correct. That should work for our solution on inserting into a linked list. I'm going to scroll down just real quick, and I'm going to grab the pointer and insert. Then what do we want? We want pointer. There are two arguments here: pointer.head.next, and then pick your number, and whatever you want to throw in there, any number, like a number like 9 or something. So 9 is the new data, and n is the position, right? N is the position that the pointer is associated with as an object, which is here. Okay? Next, the head goes to the next. As you can see, we created this for the root, and we have our linked list that has the head, and the root gives us the traversal. That's why we created that earlier. And if I run this, I him in the second index of the linked list. Okay, so that's what happened there as I grabbed my pointer to the next position. Okay, let me error out for a minute. So if I want to go to the next one, then you just go pointer to next to get to the next index. So the pointer's at the head. Pointer 2 is not at the head, so you got to go next. Pointer 3 next. Pointer 3 next. See, pointer 3 next to go to the next index. Okay, pointer 3 next to go to the end. See that? So I'm just going to go with the head and insert him into the second index for now. So you could play around with that, and we'll move on. Okay, so the next thing we're going to work on is the next data structure, okay, and the associated algorithm that goes with it. So we're going to work on the binary tree, okay. We're going to work on the root node. We're going to work on a few other things. Got to bring in the parent node, child nodes, and we're going to insert, right? So we're going to keep it somewhat standard at this point. We'll do a standard insert and traverse with the tree as well, and then we'll go from there. So we're gonna have to do some work on that tree. This is considered a binary tree for the most part. Okay, so we're gonna start working on that right now. We're still in Python. We're gonna move to Java next for the other thing we're gonna do. So we're gonna create the node here. And we have some data that we want to bring in for the constructor, for the parameter. We want to bring in some logical things that we need, like we need a left node and a right, and some data. Okay. And we'll talk about some things here in a second. So we'll stay here, and we want to set up the node when it comes to the tree itself. And the node could be anything. Okay, it should be a root node of some kind. And it's lesser values to the left and greater values to the right from the root node. So if the root node is 10 or 12, then anything going to the left would be the lesser number. You traverse to the left. If it's greater than 12, traverse to the right. See that? And then 14, if it's 14, then you say, okay, he's greater than 12, you go to the right. If 20 is greater than 14, you go to the right. If, 3 is less than 12, if the root node is 20 and you want to insert 19 goes to the left, like that. If the root node is 9, you get the idea. You bring in 2, go to the left. Is 2 greater than 9? No. Root node is 9. Is 11 greater than 9? Go to the right. And keep branching that way. This is our generic binary tree that we're working with. We won't have, we're going to eventually get to the other types of trees, or shall I say the other logic for trees, which are different, which promote a different order, right? A different traversal order. But right now, that is the order that we're working with. I call it a standard order at this point that we're gonna, work with. So here it is. Okay, let's think it through. The next thing is to insert, obviously, right? That's what I was just talking about. So insert. Bring in some things, right? Bring in some things. Okay, where's our data? Okay, our data is right there. This is exactly what I was talking about in theory. I don't have any charts in front of me, but think about a tree. So if self.data is true, okay, then keep going. The data is less than self.data. Then if it is 2 less than 9. So if the root node is 9, it's 2 less than 9, right? If self.left is empty, okay? I'm using Python here. I'm not trying to be biased, but this happens to be Python right now. Self.left is the node itself. See? Send them over there because you are less than 9, my friend. Else self.left dot insert some data like that. All right. Let's go out here. Let's go out here and try the other one. So in Python we have to do this. Okay, so now we say it's 2 greater. It's let's think. It's 11 greater than 9, like that. So let's say we throw 11 is our next number. 11 greater than 9. All right. Then if self.right is empty or null, self.right equals the node. See? Where's that node is right here. This is our root. We're creating a class to represent our root node. Gotta love it, right? We gotta use Python to help us out. Python class. All right. Else self.right.insert data, right? Okay, let's go over here to the hierarchy. We gotta just kind of return at this point. Now we want to print the tree, if you will. Where are we here? Okay. This is a binary tree that we're working on, guys. All right. Print tree. We're live here. Well, we're on Jake Coin 5000's channel, getting ready for a new course in data structures and algorithms. I'll be working closely here. Hopefully Jake will give me the call to do that soon. But this is a warm-up that we're doing here. We're just kind of solving a few problems, and then we'll go from there and try to get some courses going on this new channel that I've been invited to. So again, anybody who's been working with me in other native environments, other video courses that I've done, and so on, okay, you know that I'm big on repetition. I'm big on hands-on repetition. Yes, we have to draw charts. Yes, especially with data structures and algorithms, we got to draw the charts. We got to draw it out. How does this binary tree thing work, right? What is the traversal order that we're working with, right? Yes, that is true. We have to do that. But I'm always a kind of a code first, theory second kind of guy. Because when it's time for you to get in front of the professor who's drawing all those tree structures and all the points in between, you've already got your coding skills through Coder Jerome. So you already know how to code with me. So now we just have to connect it to the logic like a binary tree. So I want to continue to solve these problems to get us ready for our new course, okay? Coming up, hopefully, on this channel. All right. Let's print the tree. All right, let's print the tree. And let's print the data itself. And let's go to the right. Okay, so if print the tree. So if self.left, print the data. If we go to the right, then print the right side of the tree as well. Okay, so we're printing everything that is relevant. Root node is 9. Pointer.insert 2. Remember that? 2. Pointer.insert 11. Pointer.insert 14. Pointer.insert 19, like that. And then pointer dot print tree. Hopefully this will work. This is raw and we're live. Okay, great. 2911 29 and 11 is what we have. So we have lesser value to the left and greater value to the right. And of course, pay attention to your syntax and things like that. All right, make sure you're on the left and you're on the right. All right, so self.left, print, self.right, print. Okay. Let's insert something else. Pointer.insert 19. Let's get him back in. All right, so the root node is 10. Root node is 9, actually. You can play around with your tree like I am. All right, root node is 9. Anything to the left is less than 9. Anything to the right is greater than 9. So 1, right, is 1, less than or greater than 9. Is less than 9, go to the left. So it goes to the left. Is 2 less than 9, go to the left. Is 2 less than or greater than 1, go to the right of 1. See that? I know it's the console. I know the console is a pretty thing, So that's why we have to draw a diagram sometimes. So 9, 11 goes to the right of 9, 14 goes to the right of 11, 19 goes to the right of 14, like that. So picture it as a tree. We're doing the best we can here with the console. All right. The console is a great place to practice for me, and those of you that know me, we're always coding in the console. All right, so then I'm gonna switch over here to my other REPL. All right, we're gonna go into C. Okay, the C language. All right, and try to get some kind of tree-looking structure. But this time I want to do some kind of pattern algorithm, and that's going to be next on the plate for our journey through logic and algorithms. The Pascal's triangle is what we're going to work on next. All right, so those of you that, again, know me know that my name is Coder Jerome, and we're always pushing through as much code as possible with all hands on, so that when you're in front of that professor, you'll be ready, right? So again, welcome to the Jakecoin 5000 channel. I've got the privilege of doing this, preliminary practice before I get the call to possibly do a course on this channel. So thanks guys for sticking with me. We're gonna, have this one probably go live very soon with a path, right? With a curriculum, with a data structures, logic path course, so we can keep learning. So we're going to bring in some logic for the Pascal triangle. It looks like a tree. So we're going to try to make the console look pretty in C. Okay. So in C, C is a little different. We got to include some things, right? Include, a header and things like that. The Pascal's triangle, okay? It basically starts with 1, if you do the calculation correctly, and will increment going down in the tree structure. So 1, 2, 3, 4, 5, 6, and 10 is the standard setup for it, and it has a nice structure. We're going to try to get that structure going and see it in action. So it has a particular formula. All right, so all the values outside, right, are 1. So they're considered, it considers 0 understood on the outside, 1 just on the inside, 0, 1, 0, and then a space. So we have to bring in spaces to make the tree structure, so there's a physical element to it. And then the second row's formula is 0 plus 1 and 1 plus 0, making 1, 2, 3, 4, 6, 10, and 5s on the outside. Okay, so this is one of the more advanced algorithms, but we're going to try to look at more of the structure here. There's some kind of recursion involved. Okay, and it's going to take in some kind of parameter and some kind of pick something here. All right, for lack of a better variable name, A. Okay, so A minus. So we need to calculate some things here. A equals A times N. So that's the recursive formula for this Pascal triangle here. Let's go ahead and return it and get that where it needs to be. So we have our recursive formula for the Pascals, all right? And we need the actual recursion to happen here. So let's see here. We have the recursion, then we have the Pascal like that. Int n, int r. Let's return the recursive logic. So, recursion of n. I believe this is a factorial type of recursion like that. Recursion. And then we'll use our native parameters there. Recursion. Okay. Okay, so that's going to give us the nice formula we need for the Pascal's triangle, hopefully. All right. All right, we're doing this raw out the gate together. And now we need our main function And let's bring in some things. We need a row, we need a column, we need like a T and an R and a C, like that. T equals, how many, what's our total here? 0, 1, 2, 3, 4, 5, 0, 1, 2, 3. Okay, let's just make it like 6 or something. Let's scroll down a little bit. All right. For row at 0, row is less than or equal to the T, the total of the entire thing. R will increment at this point, the row. The column, okay? Column less than or equal to the column is less than or equal to the total minus row. And then, so the total minus the row, okay, which is going to give us the shape. 3 spaces here. You have to physically get in here. 1, 2, 3. Okay, 1, 2, 3. You have to be physically skillful for that. All right, 3 spaces. All right, let's go back to our column. Less than or equal to the row. And then we want to bring in some string formatting spaces as well for the string formatting symbol of an integer. Pascal's row column. So the Pascal's function there. And then we will print another line. Okay, let's print another line, and let's just make sure my braces are where they should be. They may not be where they're supposed to be. Okay, all right. So we have the shape almost where it needs to be. We have percent. We have our Pascals. We've got our column. We have our total. And we're printing our spaces. Now, if we bring him back, I may have maybe one more space than I should. Yeah, I think I had one more space. All right, that's it right there. That's our Pascal's triangle. All right, nothing more, nothing less than a space. All right. So there it is. There is the triangle in action. And that's the basic code for it using C to solve that structure for now. Let's think about something here. You think about something. The recursive formula here. A equals 1. N. What goes into N is the actual recursive formula itself. So I want to probably redo this for a second. Let's redo this one. Use A. Okay. In A. All right, let's try to do the calculation on the inside of it. Let's fix that. So 4A equals 1. Then the value that you're passing in has to be greater than 1, and the value in the other direction. You gotta get some braces there. So A equals A times that value to get the actual calculation, which is, in this case, 0. So the N should be greater than 1. the A value is multiplied by n. Then we have our recursive formula there. All right, well, that is, the closest we're going to be able to get this one. So all values outside the triangle are considered 0. So that formula got me to the outside. There's a few other things we can do here. The other one got me on the inside. And there's another formula I probably need to figure out. But we'll save that for some other time. But right now, this is what we have so far for the Pascal solution. We can, for the sake of time, we'll work on the other formula some other time, okay? Because I want to move on to the next problem, okay? And this is going to be functional logic with Java. So let's move over to Java, right? We're not biased to any one language, of course. And we'll just keep working through some stuff when we're dealing with algorithms and logic and functional logic and things like that. All right. So again, we're on Jake Coin 5000's channel, and we're going to keep working through some things. And let's switch over to our Java. Functional logic. And I want to work on a high order function, just something random from our list of things to do, okay? So we're just getting warmed up here. I'm going to go back to my list of REPLs here, go into the functional C, which is basically a C family language, okay? So we'll just use Java for that, for the implementation. You can use C, whichever one you want to use. But I'm going to look at Java for this one. This is a nice one to look at. So the high order function will either take a function as a parameter or return it. We're going to bring in some lambda expressions and things like that, and feed it through a type of encapsulation. So it's pretty cool a little piece of logic. It's a functional logical thing. So in Java, we're just going to import function for the functional logic. Okay. We should be able to get that with a class. Hopefully that should work for us. We need to follow the rules of Java. Static void main. Okay, some arguments here, okay? Let's go ahead here and look at how we're going to bring in our generics and things like that. So we need lambdas, we need generics, we need some other things for this one. All right, so we have to go ahead here and make this one private with generics. All right, pick anything you want here. We want to make our own print function. All right, and we're going to borrow that guy at the top. Okay. We're going to call it, whatever you want, and then make a generic T. All right, you just want generic T for now, as a standard, and then just print out the pointer. System.out.print the pointer dot, bring in something from the library. It's the T generic, object there. All right, so now we have some generics we can work with through some kind of encapsulation. We're trying to do some cubing on numbers and things like that. Pretty interesting, actually. One of my favorites is the high order functions when it comes to functional logic by far. We need some kind of collection here. Right, some kind of data structure for a collection of numbers. It's an array. I don't know. Make it eventful. Make it look good. Okay, that's cool, right? Now use the function from the library and pass in the generic data types. And we want to cube something, right? Using generic T. Okay? Pretty cool here. I like this. So now we can say, okay, we have our, variable that we named it from our function, passing in generics, which is the integer that points to the generic T. See that? So the T here will apply as an inline function that points back and allows us to reuse all of this stuff. So when we loop through it, okay, like that, then we can use our print function and pass in the cube and then the collection of T. Oh, of I, of course. So that's what that's a small little implementation on a higher order function using Java. So you're gonna loop through the collection, right? Using an array there. Use your function from the class from the library. Give it the inline function of cubing your generic. Then, as you loop through the collection, you're going to grab the function that you just created using your generic function T and E. See that? So, he is the first argument. Cube is the argument to this entire thing. See? That points to what? This, which is pulled from this, from that parameter, which is the pointer. See the pointer? So system.print, right, out the print line, pointer that apply the generic. See? T. Okay? So T is then used to cube this guy, right? And then we're going to the generic T object is now the collection itself. So now we can take a look at it, right? We can see what's going on here. At least that's the logic. And compiling should work. Okay, so there's the answer right there. So that should work. So we're cubing each value as we loop through the collection. So that is simply saying, okay, send in the logic for cubing that is set by the function from the library and feeds through the pointer and we assign it the cube variable. Okay, we put it in there as the argument, and then the second argument is the collection itself. So loop through each one, 0, 1, 2, 3, 4, and cube them one at a time. So that's our last exercise, or our last problem for this warm up. Okay, guys. So again, I thank Jake Coin 5000 for having me on his channel today. This is a warm up because we're trying to get ready for a new course in problem solving through algorithms, functional logic, and data structures. All right, guys. So I'm Coder Jerome, and I'll see you again. See you again real soon.